So this is a complex-ish problem. It's more just got multi-steps. And so when you have one of these multi-step problems, I would encourage you to just, have your x, x1 equals, what is it? So read the question. We've got, let's draw a picture here. We've got a toy rocket that's being launched at a very steep angle, right? This angle here is 77 degrees. And when I see these angle things, I'm going to make a triangle, and I'm going to find Vx and Vy using basically, and we know the speed of this, what is 12.4? So you'd say 12.4 sine of 77 and 12.4 cosine of 77. Now think about it. One of those is the x and one of those is the y. So that's x1, because it's then going to go, woo, boom. It's going to be kind of a really big, loopy, arcy thing. x1, of course, is 0. It's starting x1. x2, we don't know that. That's actually question C. That's the range. V1 is going to be one of these two. So you're going to know this number. That number is known. Okay, for known. The acceleration in the x direction is 0. The time, we don't know. Now for the y's, so let's write the y's here. y1 is 0. y2 is, well, we don't know that. That's be like a height or something. Well, at the end, when it finally lands, it's 0 because it's going to land on level ground right back to the same spot, right? V1, y, is the answer to one of these questions. The acceleration is negative 9.8, and the time is unknown. But when we have all this, we can start with the red, which is asking for the total airtime. So that's what you're going to do, is solve for time first. So y2 equals y1, 1 plus v1y. Again, we do know this number too. That's k2, and call this k1, times time plus 1/2 at squared. You can solve for all of this, and this will give you the time. So that's a get question A. The max height. Now on max height, I have found the easiest way for max height is to use equation 3, v2 squared, and this is in the y direction, super important, is equal to v1y squared plus 2a times the change in y. And now we can trying to find the change in y. The acceleration is 9.8. The v1y, we know that from here, the k2 I'm calling it. v2 at the top of the arc, what is his speed? It's 0, right? Because he will stop for a moment in time. And then you can solve for the max height. Got the max height. The range, once you know the time from part A, if you will, you can then plug it into the same equation in the x, boom, and you can say x2, that's the range, is equal to x1, we know that's 0, plus v1xt, and that's also known, that's our k, I'll call it k1, times the time. Now the time you'll use is this time, plus 1/2 at squared. But remember that 1/2 at squared is 0 because the acceleration in the x-plane is 0, and you can solve for x2. And what is its final velocity? Now, this is a little bit tricky. If you have the same thing on the you have to do is you have to add up all the x's and all the y's. So what is the velocity in the x at this point right here, and what is the velocity in the y? And when you find those, you'll take the velocity in the x square. If this is the velocity in the x, and this is the velocity in the y, you use Mr. Pythagoras to add them. So you don't just add them, you'll know these, and you do this squared plus vy squared square rooted. So what would be the velocity in the x? Now if you think about it for a moment, it's actually going to be, it's going to continue to move in this direction, right? And so it's not really changing what's the velocity in the y, and then you will add them up. This is a very easy one. It's actually intuitive if you think about it. And sign matters. That's my hint.